Hello, everyone. Thank you for listening to our talk on a cloud-based serverless microservices application for digital preservation. This is presented by Yinlin Chen and Alex Kinnaman from Virginia Tech with support from James Tuttle, also at Virginia Tech. So today, just a quick run through of what we'll be chatting about. We'll give an introduction to what we're doing at Virginia Tech, a bit about our problem statement and then our solution to those problems, an overview of our entire infrastructure, as well as an overview of the performance and cost of our decisions, and then finally a conclusion and future work. So digital preservation, as we all know, combines policies, strategies, and actions that enable access to digital content over time. And the digital preservation strategies and actions address content creation, integrity, and maintenance. Since content integrity includes verification methods and routine audits, we want to make sure that we can check the fixity of the content held on our preservation storage systems at regular intervals. This helps us to maintain logs of fixity information and supply audits on demand, and also helps our ability at home to detect any corrupt data. So this is an overview of the Virginia Tech Digital Library platform, which we are in the process of building. And you can see that it is built on several different types of microservices. And for this talk, we'll be focusing specifically on the Fixity service. And we'll get a little bit more into this diagram as the presentation moves on, but this gives you kind of an idea of the overall system that we're working within. So our issue is that we needed to move our data from on-premise servers to cloud vendors in order to reduce all of our maintenance obligations and significantly reduce expense. Cloud vendors such as AWS S3 and Azure Storage advertise a 99.9999, etc. of data durability of objects over a given year. However, we want to make sure that we can verify the data from these black box vendor systems. We want to make sure there's file integrity from our version to their version, and also get notifications when custom events occur. So our solution is to develop a cloud-based serverless and microservice application. This allows us to run large amounts of fixity creation and validation asynchronously. It also allows routine checking based on the policies that we have defined in our digital libraries department. The system can scale up and down depending on the amount of content we need to move. And this way, what's really helpful to us is that we only have to use the resources that are required. We don't have to buy one package and only use a few things. We can tailor individual components. And of course, we want to make this as automatic as possible without any human intervention or as much system maintenance. So now I will pass it to Yinlin Chen to get a deeper sense of the system and the performance and cost.
The entire infrastructure is serverless. We use all the AWS managed service. And in this infrastructure, we have two parts. One part is we implement several microservices to do the Fixity work. So retrieve the files from the S3 and do the Fixity check using microservices. In here, we implement 3 Lambda to do that. And another part is to, based on the policy we implement, we can define different rules and generate a report using AWS Athena. So, and finally, based on the result, we can notify to our users. So inside this serverless Fixity work, we have 3 Lambda functions implement microservice. They connect to each other and put inside the AWS state functions. So these functions read the files in the S3 bucket. Then first, they retrieve files from S3. Then after the file is retrieved, then do compute the checksum. We use ND5. Then finally use the validate the checksum with the original ND5 and to make sure it's working or not. And then we save all the result into another S3 bucket to further analyze these log data. And we can use a command line to trigger this process, or we can use a web interface to trigger this process too. So this is our state function workflow. So in here, we can see there are the green color is functions. So we can see we retrieve the files, and if the file is retrieved successfully, then we will do the checksum compute, then finally do the validation of the checksum. And you can see in here, we can wait 4 minutes, 12 hours, or 4 hours. This is because we have all kinds of different files, and some files stay storage in the AWS standard storage, which is we can retrieve very quickly. And some files, because it's archived files, so we store in the S3 Glacier. So we will take these files will take at least 12 hours to retrieve. So we support multiple scenarios. So no matter this file is stored in S3 standard or Glacier, we're able to retrieve this and do the fitting check. So this is a workflow for the fitting check. So you can see in the S3 they have different storage classes from standard to S3 Glacier diff archive. So for the standard, we can retrieve very quickly, like less than 4 minutes. 4 minutes. For the Glacier, we will need 12 hours. And then you can also see the pricing here. So the files stored in the Glacier is more cheaper than the standard. So based on the different kind of files we store in different S3 storage classes, and we all can do the fitting check for all these files. So this is a history of how the state function events. So you can see every operation they will have a timestamp, and you can see the total execution time for this example is like 39 seconds. And you can see we can see all the lambda function being executed, and also we can see all the lambda log to the CloudWatch logs. So everything is recorded, every single step is recorded. So we can get all the information we need to do the analyze. And this is another part. So we have different preservation rules. So we can, based on a rule, we implement lambda. Each rule is a condition inside this lambda. And we connect this with the CloudWatch. So based on rules, we execute the lambda functions. And they will query the data in the Amazon Athena from the log files. We can do the queries, and based on the rule we defined to trigger the state function and to do the Fixity work. And we also apply the Amazon SQS, so we can support to process thousands of files all at the same time concurrently. So no matter is today we need to do a Fixity for 100 files or 1,000 files or 10,000 files. We use this approach to support that. So we can do Fixity check for thousands of files very quickly. So this is a sample of, we record everything, all the Fixity result in the S3, and we use AWS Athena service, so we can do use basic SQL queries to gather all the information we need. Even with very complex scenarios, we can able to write a SQL query to get a report we need. So you can see here we could how long will it take, and all the information if this Fixity check is a match or not, when this Fixity check being done. This table show all the information. So underline is just like a text file stored in S3, but we can using the AWS Athena service, we can see it's like the database, and we can use SQL query to query all the results we need. And this is the performance. So we test from size 3 megabyte to 800 megabyte. Our current setup is to focus on the image data. So the largest ones like about 800. And in the future, we will try to do this on the video data. So video data can be gigabyte, and we will do that in the futures. And you can see here, we process over 1,000 data. That's in 40 seconds. So we can do this very quickly. And the cost, because right now we just use a set of our preservation data is around 500 gigabyte. So mostly it's just free to us because AWS has free tiers. So mostly it costs nothing to us. And we do several tests, and based on this data to do multiple different kind of tests, like multiple runs, and all the costs during this time just like $2. So it's like nothing to us. So because we use serverless infrastructure, so if we didn't use the resource, we don't need to pay anything. And we try to want to compare these to if we use instance, but we think about we don't want to waste this kind of money because instance is built by ours, and also we need to write a program to support can process thousands of files concurrently. It will take a lot of work. We don't want to spend the time or money on that, but you can see the cost is very low to us. Okay. And the conclusion, so we can see using this approach, we save a lot of times, and we can just like based on our rule, we have a lot of feasibility because it's just multiple microservices to connect together. So we can tune performance and the cost for each single microservice. And so there are many combinations we can choose, and we can test and to reduce the cost and improve the performance. So in the future, we will try to support more preserving data like the videos, and continue to improve our performance and reduce costs, and write the reporting tools for the AWS Athena, and support more different kinds of rules. Right now, we just support some basic rules, but in the future, we will support more kinds of rules for the presentations. That's it. Thank you.